Here is a very important question. We'll find the asymptotes and thereby the domain for tan and secant function, and then also look into their period and range. Let us enjoy the journey of learning. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are looking into domain, range, and period for each of the following functions. The functions are y equals to 2 tan x by 3 and y equals to 3 secant pi by 2x minus 1. So let's begin by writing domain. As far as tan and secant functions are concerned, they do have vertical asymptotes and there are restrictions in the domain. So you have to be slightly more careful while writing their domain. Well, in case you want to learn directly from me, feel free to send an email on Global Math Institute. So let's begin with the part A, which is y equals to 2 times tan x by 3. So tan function has restrictions, as you know. If I sketch the function, let me sketch it here, then the graph of tan is kind of like this, with vertical asymptotes. So when tan x is concerned, then the vertical asymptotes are from minus pi by 2, there's 1, and then every multiple of pi by 2, right? Every odd multiple. Those are the asymptotes for tan x. Now, when you have tan x by 3, it really means what? It means horizontally stretched by a factor of 3. That means they get multiplied. Do you see that? So therefore, from here we can write down the domain of the function. X belongs to real number where x is not equal to. So, so normally it is 2n plus 1 odd multiples of, normally it is 2n plus 1 times pi by 2, right? But since it has been stretched by 3, it will be 3 pi by 2. You get the idea. So odd multiples where n belongs to a set of integers. So that is how we are going to write domain of this function, right? As far as the range is concerned, you know, range is all real numbers. Period. Now, for period of the function, since the period for normal tan is pi, in this case you can see that the period is 3 times pi. So period is 3 pi. Is that clear to you? Right? So I hope this concept is clear. Now let's look into part B. So we're given the function y equals to 3 secant pi by 2x minus 1. As far as domain is concerned, there are restrictions on the vertical asymptote, correct? Now, let's figure out what is the period of this function and what could be the restrictions on the domain of this function. So let's try to understand how we can sketch this function from cos function, right? So if I have a cosine function, we could draw something like this, correct? Where it starts and that is the end of one cycle, correct? What is the period of this cycle? Let's write down the period. Period is 2 pi divided by pi by 2, which is 4. So, so for this function, if the period is 4, then these points will be at 0, 1, 2, 2, 3, and 4, correct? So as you can see, for secant, the vertical asymptotes will be at 1 and at 3, correct? Similarly, it will also be there at minus 1 and so on, correct? So basically, the secant function will be kind of like this, right? So as far as the asymptotes are concerned, there'll be a 1 and 3. So we can write that domain of this function is what? Domain is x belongs to real numbers, where x is not equal to odd numbers, right? 2n plus 1, where n belongs to integers. Makes sense? So that is how we are going to get the domain of this function. Is that clear to you? We have already found the period, which is 4 units. Now, let's look into the range part. Since the function is translated 1 unit down, so everything will come 1 unit up, right? After it gets multiplied by 3. So basically, if you see, this was 3, right? And this is minus 3, correct? Now, if I bring it 1 unit down, in that case, the range will be y belongs to real numbers, but y will be greater than equal to 2, right? Or y is less than equal to minus 1 from minus 3 will give me minus 4. So if you translate this 1 unit down, you can see the range. There'll be either greater than 2, equal to 2, or less than equal to minus 4. So that is how we get the range of this particular function. I hope the concept is absolutely clear. Free, please feel free to write your comments and suggestions. Thanks for your time and all the best.